You're hungry. You open up an app, tap a few buttons, and just like that, a tiny little car starts crawling across a map, heading straight for your door. It really does feel like magic, doesn't it? But it's not. It's this incredible symphony of technology working perfectly in sync behind the scenes. So let's pull back the curtain and see how it all actually works.
I mean, we've all been there, right? Staring at that little dot, watching it move. But have you ever really stopped to wonder about the insane chain of events that makes it possible? How does the system even pick a driver in the first place? How does it guide them through a busy city? And how does it update you every single second along the way? That is exactly what we are going to break down, piece by piece.
So here's our game plan. First, we'll look at the core problem they're trying to solve. Then, how the perfect driver gets chosen. After that, how they find their way, how their phone talks to yours, and how the system knows they've arrived. And finally, we'll zoom out and see where else this amazing tech is hiding in plain sight.
Okay, first up, the modern delivery problem. Because, it's not just about getting something from point A to point B. It's way more complicated than that. It's this delicate, high-stakes balancing act with a ton of moving parts.
And this quote right here from DoorDash's engineering team just nails it. The system has to make two completely different groups of people happy at the exact same time. There's you, the hungry customer who wants your food like yesterday. And then there's the driver, who needs to work as efficiently as possible to make a living. It all boils down to this: speed for you, efficiency for them. The entire system is built to solve that one critical puzzle.
So, keeping that big challenge in mind, how in the world does the system pick the absolute best person for your specific order out of everyone who's available? Well, this is what engineers call the dispatch problem.
And this is definitely not a lottery. It's more like a super high-speed, high-stakes matchmaking service. It's searching for that one single, optimal choice that perfectly maintains that balance we were just talking about, your speed and their efficiency.
And it all happens in 3 basic steps. First, the system just generates possibilities. Who's nearby? Hey, can we bundle this order with another one from the same restaurant? Second, it uses machine learning to literally predict the future. How long will the food take to cook? What's the traffic like? And maybe most importantly, will this specific driver even say yes to the offer? And finally, a massive optimization model weighs every single one of those factors, scores all the potential matches, and makes the final call. Send the offer now, or maybe wait just a few minutes for an even better option to pop up.
All right, so the offer is sent and it's accepted. Our driver is officially on the move. But as we all know, the real world is messy. And a perfect, uninterrupted signal from space is a luxury you just can't count on.
Now, the foundation for all of this is, of course, GPS, the Global Positioning System. And put simply, the driver's phone is constantly listening for these tiny signals from satellites whipping around the Earth. By timing how long it takes for signals to arrive from at least 4 different satellites, the phone can triangulate its exact position on the globe. It's basically a super high-tech game of Marco Polo, but with space robots.
But here's the catch. We've all seen this happen. You drive into a tunnel and your navigation app just freezes. GPS signals need a clear line of sight to the sky. In big cities with those towering skyscrapers, what they call urban canyons, or, in any underground parking garage, that signal is just gone. So how does that little car keep moving so smoothly on your map?
Well, the answer is this wonderfully named technology called dead reckoning. Think of it as a really smart backup plan. When the GPS signal drops, the system basically says, okay, I know exactly where I was 1 second ago, I know how fast I was going, and I know which direction I was pointed. So I can make a really good guess about where I am right now.
And dead reckoning comes in 2 main flavors. The first is automotive dead reckoning, or ADR. This is actually hardwired into a car, reading data directly from the wheels. It's incredibly accurate. But the real game changer for the gig economy is untethered dead reckoning, or UDR. It uses the sensors that are already inside the driver's phone, the accelerometer, the gyroscope, to do all that math. No wires, no physical connection to the car needed. And that's why it's perfect for delivery drivers, e-scooters, bike-sharing services, you name it.
Okay, so the driver's phone knows where it is even if it's in a tunnel. But how does that information get all the way from their screen to your screen in what feels like real time? Well, that requires a constant, invisible conversation.
See, the way your web browser normally works, where it asks for a web page and then gets a response, is way too slow and clunky for this. It would be like your phone having to send a new text message every single second asking, "Where are you now? Where are you now?" It's just not efficient. Instead, you need a persistent two-way connection, a live data stream that just pushes updates instantly.
So think of it like this. A technology called WebSockets opens up a private, continuous telephone line between the server and the phone, so they can talk back and forth constantly. And MQTT? That's like a super efficient, lightweight language they speak over that line. It uses these tiny, coded messages instead of long sentences to save data and battery life. And by speaking this special language inside that private telephone line, it helps the messages sneak past security firewalls that might otherwise block them.
And you can actually see the trade-off right here on this chart. Running MQTT directly over a standard internet connection is a little bit faster, sure. It can handle over 6,600 messages a second in this test. But running it over WebSockets, while it's a tiny bit slower, is way more compatible and reliable out in the messy real world. It's a small performance hit you take for the huge benefit of making sure the data actually get through no matter what.
Okay, so the system knows where the driver is, and it can tell you instantly. But how does it know when those key moments happen, like when the driver is just around the corner from your house? Well, it does this by drawing invisible lines on the map. You know that notification you get that says, "Your driver is arriving now"? That isn't triggered by a person hitting a button. It's completely automated. But how does the system know the precise moment to send it?
The technology is called a geofence. And honestly, it's exactly what it sounds like. It's a virtual fence drawn around a specific geographic area. So the system creates one of these fences around the restaurant, and it draws another one around your delivery address.
And here is where the magic happens. When the driver's phone crosses one of these invisible boundaries, it acts like a digital tripwire. Crossing the geofence around your house is what triggers that "Arriving Now" alert, and leaving the geofence around the restaurant is what automatically updates the order status to "On its way." It's so simple, but it's incredibly powerful for automating the entire delivery process.
Now, we've been talking a lot about food delivery, but this amazing combination of machine learning, dead reckoning, real-time communication, and geofencing, it's really a hidden engine that's powering a huge part of our modern world.
Just think about it for a second. This exact same tech stack is used to manage entire fleets of shipping trucks, to help you find that rental scooter you left in a parking garage, to track livestock on a massive farm, to make sure life-saving medicines stay cold during shipment, and even to help car insurance companies offer you discounts for being a safe driver. It is absolutely everywhere.
So, to wrap this all up, that simple little dot moving across your map is actually the end result of this deeply complex, hidden engine. An engine that uses machine learning to make predictions, dead reckoning to navigate through signal blind spots, specialized protocols to have an invisible conversation, and geofences to automate all the key moments.
But it does leave us with a pretty big question for the future. I mean, this technology is unbelievably convenient, but it also means that almost anything can be tracked, anywhere, at any time. So as we keep moving forward, the real challenge for all of us is going to be figuring out how we embrace all the benefits of this hyper-connected world while still protecting the personal privacy that we all value.